equations. Number 1, insert 4 geometric means between 1/2 and -16 over 243. This means to say that if we have 1/2 as the first term, then we are missing here 1, 2, 3, 4. 4 terms. And then followed by -16 over 243. These 4 missing terms are what we call the geometric means. And what are these terms? We are given that a sub 1 equals 1/2, n is equal to 6 because after inserting 4, then there will be a total of 6 terms. Then a sub n is the last term, which is -16 over 243. A sub n is the last term, or the 6th term in this case. Now we need to find the value of r, the common ratio, so that we can find the second term, third term, and so on. Since we have the 6th term, we're going to write an equation for the 6th term using a sub n equals a sub 1 times r raised to n minus 1. So our a sub n, or a sub 6, is -16 over 243. This is equal to a sub 1, 1/2, times r raised to n minus 1, or 6 minus 1. That will be -16 over 243 equals 1/2 times r raised to the 5th power. We multiply both sides by 2 in order to eliminate this 1/2 here at the right. And this will be 2 times -16, -32 over 243 equals r to the 5th power. So we will get the 5th root of -32 over 243 and also the 5th root of r raised to the 5th power in order to get the value of r. So r equals -2/3. Again, the 5th root of -32 is -2, and the 5th root of 243 is 3. So the 5th root of -32 over 243 equals -2/3. And since we now know the common ratio, we just multiply this common ratio with the first term to get the second term. So a sub 2 equals the first term 1/2 times r -2/3. That simplifies to -1/3. To find the next term, we do the same thing. We multiply this second term, -1/3, by the value of r. So this is equal to 1 times 2, 2, and 3 times 3, 9. Negative times negative is positive. And to get the fourth term, again, we multiply 2 over 9 by the common ratio. So 2 times 2 is 4, 9 times 3, 27. Positive times negative, negative. Therefore, for the last term, or the last geometric mean that we're looking for, a sub 5, this is a sub 4, -4 over 27, that's the common ratio again, that is positive 8 over 81. Again, 4 times 2 equals 8, and 27 times 3 equals 81. So, we have now the geometric means that we're looking for, -1/3, 2 over 9, -4 over 27, and 8 over 81. For our next example, insert 3 geometric means between square root of 5 and 81 is square root of 5. So this is square root of 5, and then we will insert 3, 1, 2, 3. 3 geometric means, then the last term would be 81 is square root of 5. So a sub 1 equals square root of 5. A sub n, the last term is 81 is square root of 5. N is equal to 5 because after inserting 3, we will have a total of 5 terms. Again, we need to find the value of r. Since this is a sub 5, we will write an equation for a sub 5. So, 81 is square root of 5 is equal to a sub 1 is square root of 5 times r raised to 5 minus 1. Again, our a sub n is a sub 5. It's 81 is square root of 5 equals a sub 1 square root of 5, then r raised to n minus 1, 5 minus 1. 5 minus 1 is 4. Let's divide both sides by square root of 5. So we can cancel that square root of 5, And we are left with 81 equals r raised to the fourth power. To find the value of r, we must get the fourth root. The fourth root of 81 is equal to the fourth root of r to the fourth power. Therefore, r is equal to 3. The fourth root of 81 is 3. So the common ratio is 3. So we must multiply this 3 with the first term, square root of 5, to get the second term. So square root of 5 times 3 equals 3 square root of 5. To get the next term, a sub 3, we multiply the result, 3 square root of 5 times 3 again, that would be 9 square root of 5. Why? We multiply 3 and 3 to get 9. So 9 is square root of 5. And to find the next term, we multiply this 9 square root of 5 with 3 again. That is 27 square root of 5. 9 times 3 is 27. Therefore, the geometric means that we're looking for are 3 square root of 5, 9 square root of 5, and 27 square root of 5. For our third example, insert two geometric means between 8 and 1000. So our problem looks like this. We have 8 and then we insert two geometric means, and then the last term would be 1000. So we are given that a sub 1 is equal to 8, a sub n equals 1000, and n is equal to 4. 1, 2, 3, 4. We have 4 terms. Still, we need to look for the value of r. Since this is a sub n, or a sub 4, then a sub n is equal to a sub 1 times r raised to n minus 1. Or a sub n is 1000, a sub 1 is 8, times r raised to n is 4, 4 minus 1. Or 1000 equals 8 times r cubed. We divide both sides by 8, so we cancel 8. And 1000 divided by 8 is 125. Therefore, r cubed, this r cubed, is equal to 125. We get the cube root of r cubed so that we can get the value of r. And that is equal to the cube root of 125. The cube root of 125 is 5. Therefore, r is equal to 5. And just like what we did in the previous examples, we will multiply the first term, 8 times 5 equals 40, to get the second term. And then to get the third term, a sub 3 will be the result earlier times 5, that is 200. So the geometric means that we're looking for are 40 and then 200. For our next example, insert a geometric mean between 7 and 63. So we have 7 blank 63. What is this term here? We are given that a sub 1 equals 7, a sub n is equal to 63, and n is equal to 3. 1, 2, 3. There are 3 terms. In our first solution, we will look for the value of r. Just like what we did, okay, we write a sub n equals a sub 1 times r raised to n minus 1. Or 63 is equal to a sub 1, 7 times r raised to 3 minus 1. Or 63 equals 7 r squared. Divide both sides by 7. Cancel 7. 63 divided by 7 is 9. 9 equals r squared. Now we get the square root. Square root of 9 equals square root of r squared. And square root of 9 is positive, negative 3. So r is equal to positive or negative 3. So to find the second term, we multiply 7 by positive 3, we get 21. Or if the common ratio is negative, then the second term can also be equal to 7 times negative 3 equals negative 21. So the two answers are 21 or negative 21. For our alternative solution, actually we have a formula for the geometric mean when we're looking for a single geometric mean, wherein the geometric mean is equal to positive negative square root of AB, where A is the first term and B is the last term. And the geometric mean is the term in between them. So, if we use this formula, then the geometric mean is equal to positive negative square root of a times b, 7 times 63. So that is positive negative square root of 441, and that is positive negative 21. You can try this. Insert two geometric means between 7 and negative 1029. Kindly comment your answer